3. Hello, hello. Let's see who's on. Izar, Ivan, Victor Montano, welcome. And there is a magic button. Okay, so Izar, Ivan, and Victor admit all. Okay, here we go.
Good morning.
Let me test my mic. Yes.
Can you hear me?
I can hear Izar. Let me get the volume up a little bit more here. Victor,
Yes.
your microphone is unmuted, which is good. Izar, could you unmute your microphone? Unless you're eating potato chips or something and it's really crunchy.
Sorry.
Well, hello, we're starting to hear some sounds. That's good. 31 and save. Cool. Very nice. So for the people who are on so far, welcome back from spring break. Hope you had a good rest. Let's go around and do a check-in and see how you guys are doing. I'll start with, let's see, Ivan, I see your mic is, and Victor, your mic is unmuted. Izar, your mic is also unmuted. So Izar, why don't you give us a recap? How's your past weekend?
Really good. I mean, starting and everything, you know.
Mm-hmm. Control P. Ivan, how's your week been?
Doing good. Can you guys hear me?
Yeah, hear you just fine.
Okay, cool.
Yep. You'll grab something off the printer. Victor, how's your week been?
George?
Yes. Okay. All right.
Can you hear me?
Barely. Can you turn up your mic some or make some kind of adjustment on that mic, Victor? Because you're very faint. Hello, 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 hello.
What's about now?
No, oh, that's wonderful.
Okay.
That's terrific. We can hear you just fine now. Okay, so let's take a look here. Go to here. Peek on Canvas. And go to dashboard and go to 51. So I have a question. As you should have Canvas on your screen also, so we're both looking at the same thing, please. So when you have Canvas on your screen, signal me back and let me know that you have Canvas on your screen.
I'm on it.
Canvas.
Okay, cool. All right. So as you're looking at Canvas on your screen, how many of you see on the far left-hand side the black band that has account, dashboard, courses, calendar, inbox? You all see that's a standard arrangement, yes?
Yes.
I'm going to do a share here. Let's see, there's also a chat. Somebody had a chat. Well, yes. Thank you, Ivan. He said hi to everybody. All right. Manage 6 people. So let's see who else is here. Gerardo came in. Admit all. Okay. And let's go ahead and remove the chat for right now. Okay, I have to keep an eye on this screen as people come in. It turns out they're not automatically allowed to come in. I have to notice that they're trying to get in, and if I miss that notice, then we miss somebody coming in. Let's take a look here. Yeah, yes, Edwin, we see you. Well, we see your name. So if you could unmute your microphone and say hello to us, that would be great. Gerardo Sanchez, if you could unmute your microphone and say hello to us, that would be great.
Hey, this is Gerardo's here.
Yay, thank you very much. Cool. Okay, so I'm going to do a share of a screen, and let's go here and share. All right, so you should be able to see my screen presently. You should be able to see my canvas on the screen. Is that okay?
Yes.
So as you're looking at my canvas on this screen, notice this is our class, ESYS 51. And then on the left-hand side, I have home, I have studio, I have announcements, discussions, grades, syllabus, modules, Zoom. So 1, 2, 3, 4, 5, 6, 7, 8 links that are live on the left-hand side. So I'm going to start with Izar. Izar, can you see Zoom? I mean, can you see Studio?
Nope. I just see home, announcement, discussion, grades, syllabus, models, and comfort zone.
So Izar is a no. Okay, Ivan, can you see the Studio?
I don't see Studio.
No for studio. Okay. Edwin? Can you see studio?
I'm just checking in right now. Logging in.
Okay. All right. We'll get back to you in a moment. And Gerardo?
No, I cannot.
Huh. Okay. All right. That's a no. I wonder why that is. That's so bizarre. Let's see. Do you have a settings button that's on the bottom, like what I'm pointing at with my mouse?
I do not.
Okay. So all you see is the list of 7 items down. You can see Confer Zoom, yes?
Yes.
Okay. That is really interesting. Okay, I'll have to check with IT on that. However, what I did was, did you see my most recent message that I moved the instructional video from Studio? Because if you were able to click in the Studio, you would be able to see this screen information. You would see that there is a sound pressure level meter tutorial and a Series 2R tutorial on the TINA circuit synthesis program, a simulator program. So let me go back to home. What I did was I did move it into week 2. Come back here. Move it into week 2. Open up the switch for week 2. And you will see the lab sound pressure level meter. So if you click on that, can you see this big blue box with the white arrow in it?
Yes.
Izar? Okay, yes. Cool. Click that button for just a moment, if you would, everybody, and just see if it plays on your side.
I already did the project.
Cool. So you were able to see it just fine.
Yeah, I was able to play it really good.
Good. All right. All right. And so let me see. For the yes, see video. All right. So let me go. Who was the one that said yes? I couldn't get the name.
Victor.
Victor. Okay. So Victor is yes for seeing the video. And Izar, can you see the video? Does the video launch on your end?
Yes.
Okay, that's a good. And Ivan, does the video launch on your end?
Yeah, it works for me.
Cool. All right. Let's see. Admit Brandon Nguyen. Hi, Brandon. Welcome to our class. I need your microphone on, and if you want, you can turn on your video also. So let me continue. Gerardo, do you have your video running?
Yes.
Okay, cool. And Edwin, are you up in Canvas yet?
I'm on Canvas. I don't see that I have access to Studio.
Okay, then on week 2, so go to week 2 and look for the container that has week 2 lab sound pressure level meter. Open it up, and you should see what I have on my screen, this big blue box with a white triangle in it. And press it and play. And same thing with you, Brandon.
Yes.
Okay, are you on Canvas?
No, I'm actually, I don't know how to do this video call and use my computer at the same time. Oh wait,
Are you sitting in front of your computer?
Yeah, I am.
Cool. Okay. All right. So the video call is on one function of your computer. You should be able to minimize the screen of the video call so it doesn't occupy your whole screen. So the first thing to do is to reduce the size of the video call. Then you can see the rest of your computer screen.
Got it, sir. Got it.
Okay. There you go. Because, yeah. And then you should be able to get on the Canvas, and we just want to check and see, well, how everybody's doing on this. So while our friends are still checking their videos and seeing how everything is working, okay, so I'm going to put down attendance, and I got to keep my eye on 2 screens here. Okay, so yes, and Victor's here, Brandon here, Edwin, Gerardo, Ivan. Okay, this is a pretty good start. Concerned about some other people that aren't here, but Okay, and there's a chat.
Sound pressure.
Yeah, no studio on your end. So got that, Edwin. That's fine. Then, all right, Edwin, are you able to run that video on your side? Does it run?
Yeah, I got it to run. It's playing.
Cool. Okay, that's great. And no studio on your end. And Brandon?
I do see the video.
Okay, and can you click it and see that it works?
Yeah. Sorry, it's loading.
Yeah, that's okay. It's a marvelous technology we have, regardless of the fact why I don't, why it's not in studio. Having it in studio is a nice container for students for a number of reasons, because it also has captioning, which we're not able to see in this method of you guys clicking on. So now that you know where to find it, who has actually watched the video?
I did.
Okay, who was I?
Victor?
Victor. Okay, Victor, you've actually seen the whole video.
Yes.
Excellent. All right. So as you've seen the whole video, who else has seen the whole video other than Victor? Nobody else? Okay. So Victor, as you have seen the video, did you have any questions on it?
No, everything is clear.
Yeah, everything should be pretty straightforward. It's about an 18-minute video. I filmed that last night as I was going through the project, and it's an appropriate second week project. The most important things are to make sure that you follow the directions of the video very carefully and make note of where your negative side of the microphone is, because you get that microphone in backwards, you're going to have all kinds of issues to be concerned about. So let's see if I can do something here. Let me switch my view. Let's stop the share and let's go to, so okay, got 6 participants. Let me come down to here. Let's go to here. Let's go to here. And okay. And is there a okay, that'll take down the glare, which is good. And if I hold this guy up, is it able to focus? Oh, that's not so bad. That's pretty good, actually. And let's see how close I can hold it and have it still focus. Oh, this is really good. Wow. All right. So this is the bottom of the microphone. The bottom of the microphone has 2 leads. And, oh, Ephraim, here, hold on one sec. Admit. Okay, welcome, Ephraim. So this is the bottom of the microphone. And the bottom of the microphone has 2 leads. And the most important thing is to make sure you do not mix up the negative from the positive. If you look very carefully, this is the negative pin on this side. This is the pad. And from the negative pin, can you make out these very, very fine wires, these silver solder leads, that traces, if you will, that are going out to the periphery? Can you all see that?
Yeah, I can see that.
Yeah, and when you're able to see that is the ground wire, all right? So that is your negative wire. The other pad over here has no connections, no traces, nothing whatsoever that connects to the outside. That is your positive. So you're going to make sure that you do get negative from positive identified correctly. Any questions from any of you regarding?
Nope.
Okay, oh yeah, I'm holding at this angle, and you can see it even better because it's catching the reflection of another light that I have in the room. So the negative lead is the one that is on this side, and you can see the little traces right here, here, and here that lead to the periphery, and that's your identification of the negative lead. Also, when you look at this very carefully, it has very thin wires. They're very easy to break. If you're not careful with this, you will break them, and if you break them, you're going to have to source another part from our friends at Amazon in order to complete the project. The board identified was here, and let's hold it up this way. Anyway, you have the video. That's the most important thing I wanted to show you on it. The other thing that's also very important to identify is the orientation of the switch. The orientation of the switch as it needs to go, and I'll hold this steady if I do my best. There we go, it auto-focused. I am holding it in a position where hopefully you can see the little cavity that's on the back side of the switch. So this is a 6-pin switch. And the button is a white nylon button, and the button sticks up from the switch at this elevation. I'm going to switch this camera around. Hold on just one sec. Okay, and let it focus. And focus. Where's that lens? Where is that lens? Oh, there it is. Okay. Okay, cool. So I'm holding the switch in an orientation that allows you to see that there's a cavity that's on the back side of this particular button of the switch. If I rotate it this way, you can see that that side is completely smooth. There is no cavity, no indentation. If I rotate it another 90 degrees this way, that is also smooth. I rotate it 90 degrees this way, that is also smooth. And then if I rotate it one more time, you'll see a very distinct cavity that's on the lower bottom side of that switch. Now, the important thing about that particular cavity is that that tells you the orientation of how this switch needs to go onto your board. This switch happens to have 6 pins, and it goes onto the board. So here's the board. And let it focus there for a moment if I can hold it steady. There we go. And it has 6 holes that you can identify, 1, 2, 3, 4, 5, 6. And that cavity needs to be aligned with this white bar because the switch is only making contact with these 4 pins. The front 2 holes and the pins of the switch make no contact with anything whatsoever. The back side of the board shows it's completely empty. So that's why you have to have the switch orientated in such a way that the part of the switch shaft that has indentation has to face towards this side of the board. Are there any questions about the orientation of that switch or the orientation of the microphone?
No, sir.
No.
Okay, cool. All right, next, the other thing that comes up is this, the chip socket. And what's really nice, I've asked for, as often as possible, our kits to be updated from just having students solder chips to having chip sockets. And what's nice about having the chip sockets is it is a socket. It allows us to do the soldering of this onto the board in such a way that the heat from the solder iron will travel up the pins, but they will dissipate on the little socket devices that are here. Whereas if we soldered an actual chip itself, Can you imagine what could happen if we hit these pins with any kind of solder, iron? That heat will travel up that pin, go into the chip, and potentially fry the chip. So that is the benefit of using a solder socket, a chip socket, as opposed to soldering any chip on the board. Also, it reduces the amount of mistakes that are likely to occur. Excuse me. Most notable thing on the chip socket is that one side of this has a notch. And if I can hold this up where people can see it, do it this way, shed a little more light on this, hold steady, focused on the pins, and you'll see one side has a little notch, the other side has no notch. So one side has a notch, the other side has no notch. So the notch is really important in setting the socket onto the board. The board is identified with a characteristic notch on the diagram. Here's the outline of the chip that's going to go on the board, and there's the notch. So you have to match notch with notch. Once that is done, and you're ready to insert the chip itself, the chip itself is also identified very nicely. Let me hold it in such a way it catches the light like this. Okay. And let it focus. There it is. Okay, catching the light this way. Can you guys see that notch? Right there.
Yes.
Okay, so make sure the notches all match and life is good. Okay, all right, so those are the most notable thing about the switch, the socket, the microphone. Let's see, anything else to be aware of? I think the video is very clear about your LEDs, positive to be long, negative to be short, so get the orientation correct. The board is pretty well laid out. This is a really nice board, and you have D1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. As the board is laid out, what it is you're going to see is your first 4 LEDs. Number 1, 2, 3, 4 will be green. 5, 6, and 7 will be yellow. 8, 9, and 10 will be red. So you're given 4 green LEDs, 3 yellows, and 3 reds. The resistors are marked right on the board, not just with the R number, R1, 2, 3, 4, but they're actually marked with the resistance value, 470 ohms, and so on and so forth. So be very careful how you set up your resistors. I would recommend soldering the chip socket first and then soldering the inside devices before you solder the outside devices. The capacitors are very clearly marked this way. The capacitors are marked as C1, 2, and 3, and the capacitors are identified as being polarized. The clear side of the circle is identified as being positive, and the negative side of the circle is identified as being negative. So positive, negative. So the shaded side, the striped side of the circle is negative. The unmarked side is positive. These are polarized caps. You've played with polarized caps in your travels before. These are electrolytic caps. They are polarized, and they are identified, like your LEDs, positive to be long, negative to be short. So that's, you can tell the polarity between the leads of your capacitor. There's also a marking on the body of the capacitor and on the side of the capacitor, along with the negative lead, there's also a white painted stripe, and there's a negative symbol that's part of that white painted stripe, giving you further identification that that is in fact the negative side of the electrolytic capacitor. Do not wire these in backwards. Do not put the wrong capacitor in the wrong place. The capacitors are marked on their body, and the capacitors are also marked on the board. Any questions about electrolytic capacitors and their polarities?
No.
No.
Cool. Okay. All right. There's very specific notes that I have on each of these projects. So the important thing is not to rush through them and say, okay, yeah, I can finish them all in an afternoon. And truth be told, if you were very careful, you could finish them all in an afternoon. But without some discussion, there's more likely to be mistakes that happen, and some important lessons to be learned that are not learned regarding these projects. So don't go rushing through and finishing up all your projects in an afternoon. That's not recommended at all. Anything notable about this particular board? I've also mentioned how to do in the video, how to be concerned about your battery connection, so I won't re-explain that. I think that one's pretty straightforward. Okay, any questions about this project at all?
I have a question.
Who is
This is Edwin.
Oh, yeah, Edwin, yes.
I'm under the impression that those chips are static sensitive. Is that correct?
Well, yeah, they're static sensitive only to the point where if you've walked around a lot, and generated static prior to handling this, then it's very possible that you may cause damage to this. The likelihood of that happening is fairly low unless you happen to have heavy woolen socks and you have nylon carpeting. So if you're in a situation where you're prone to experience static electricity jumping off your fingers to the doorknob, then you have a highly electrostatic environment. And yes, to answer your question, yes, that could very well be the case. So my recommendation is, when in doubt, you should always, before handling this, try to ground yourself on something. And unless you happen to have some convenient piece of electronics around, like the metal case of your computer. If those of you who are using desktop computers and such, if you touch the back side of your metal case, not the painted part, but any metal part, aluminum or steel, you can discharge the static electricity from your body very, very easily that way, and then be able to handle this with reckless abandon, as I am right now. I haven't moved since I sat down, and my environment is very, very low in static. I would say this: don't do your projects. Do not work on your projects right after taking clothes out of the laundry, out of the dryer, because the dryer is notorious for generating static electricity, and very likely you will have static charges on your clothing and on your body right after doing the laundry. So good question there. Did that address your question and observation, Edwin?
Thank you. Yes.
No, thank you. Thank you very much for bringing that up. And any other questions that arise, please, by all means, bring it up. All right. Any other questions regarding this particular project?
No.
Okay.
No, I'm good.
Yeah, all right. So let's talk about this also then. I'm going to go back to share our screen. Okay. And in sharing our screen, since for some reason students cannot see Studio, let's go back to Home and let this stabilize. And there happens to be week 2 TINA, and week 2 TINA shows 2 circuit builds. Let's light this up. Lit up there. Cool. All right, now let me magnify this. That's nice and big. Hey, cool. Now, Brandon had a very, very pertinent question. He's running a Mac. I don't know how many of the rest of you happen to be running a Mac and not able to run TINA -T. I cannot run the simulator. Aside from Brandon, are there any of the rest of you who cannot run TINA?
That was my issue too. I have a Mac, and I cannot find any applications for Macs or Apple.
Okay, who is I?
Victor.
Victor. Okay, so Victor has an Apple.
No, but I have an old laptop. I had to delete many files in order to download TINA and the other file for another couple of files I need for school too.
Okay.
PC doesn't work on Mac.
Okay. But you were able to find a solution around this?
Yeah. I had to use an old computer I had.
It's probably fast enough for this program. It doesn't require a whole lot of speed. Okay. So go ahead, Victor.
Yeah, the other thing, multi-SIM, we use it for 54, if I'm not mistaken. I had to purchase it.
Yeah, for multi-SIM?
Yeah.
Yeah, multi-SIM. And multi-SIM, is that presently running like $35?
Yeah, about that.
Yeah, multi-SIM is that would be the suggestion that I would recommend for Brandon. So Brandon, let me aside from Victor and Brandon, is there anybody else that is not able to run this software? Okay, I'll take that as a no. So Brandon, coming back to you, were you able to find a PC solution to running the software?
I was, but can you tell me about the multi-sim though?
Let's hold off on multi-sim for a moment.
Okay.
First of all, did you find a solution that can run this software?
I did.
Okay, and have you played with the 2R circuit yet?
I did, yeah.
Okay, cool. I haven't looked at the submittals through this morning, so that's great. So I'm glad that you're able to. And so what's nice about the Tina-TI is that it is free and it can do a lot of things. Separate of this, if we didn't have Tina-TI, then yes, you can always acquire multi-SIM. And let me say this about multi-SIM. Multi-SIM is the single best $35, at least it's $35 last time I checked. When I purchased it, I purchased the student edition. I did not buy the instructor edition. The instructor edition runs $750, some ridiculous amount. And it doesn't do a whole lot more for what we need it to do. So I didn't feel like it was necessary for me to buy the $750 edition. So I opted some years ago, and it's been updated since, to purchase it at $45. And I thought at $45, that's a tremendous value for the money for all the things that it does. And it does accommodate, let's see. So Victor, in your 54, you said you had to purchase multi-SIM. Does the multi-SIM run on your Apple?
No, I'm using my old laptop in order to run multi-SIM and Tina.
And Tina, okay.
Neither one works on Apple.
Neither one, okay. All right. So, okay, that verified. I didn't remember clearly whether or not multi-SIM ran on Apple or not. And what's nice is, wow, until we outgrow this, the Tina.ti will work out just fine for us. I just found it like a week before we all met, and I said, hey, this is really, really nice, and does give us all the measurements. Now, so what we'll do is we will have lessons that are an extension of what we did in 50. In 50, we started to talk a little bit about series parallel circuits, parallel series circuits. You will be asked to analyze those as part of your online work, in addition to the hands-on soldering exercises. So let me just say that will be a standard part of our work. You will have worksheets that I'll be generating. And the key thing here is to see that you can do this on paper without having the sim in the background. Building the sim in the background and getting the measurements, all that is good because it's so easy and it's automatic. But the learning experience is to learn how to do it on your calculator with pen and pencil and truly working your way through. So I'll be generating some more content via these videos that will show you step by step how to reduce a series parallel circuit and do your analysis. So that being said, now I know where we stand with respect to Tina. So let me do a check off verbally. So Ivan, you have Tina, yes?
Yeah, Tina's working fine for me.
Okay, excellent. Gerardo?
Yes.
Edwin?
Yes.
Brandon,
Yes.
Victor is yes, and then Izar
Yes.
and Ephraim.
He said on the text there on the
chat.
yeah, he's got some answers there.
Chat. Okay, let me keep that window open over here. Okay, have not tried Tina. We'll try after class. Have Windows. Oh, that's cool. All right. That's very good. Fantastic. Next. All right. So since we have our gathering, 5, 6. Since we have our gathering, what I'd like to do is switch back to a different camera and actually go through a series parallel series analysis with you. So can you pull out your calculators, please? And I'll get the camera set up. And all right, that's pretty good. Something like this. Okay, that looks like it's focusing. I'm going to stop the share on this screen. And let's go to, all right. Okay, cool. All right, suppose I happen to have a circuit, and the circuit looks like this. Voltage source, a resistor, comes down. I have a node A, I have a node B, and then over here, a resistor, and B. So I'm going to make this R1, R2, R3, and R4. And this will be a 20-volt source, let's say. And then somewhere down here, I will have a V, I, R for R1, 2, 3, and 4. Okay, can you see the circuit clearly? Can you see my chart at the bottom clearly?
Yes.
Cool.
Yes.
Okay, excellent. So this is what we're going to do. I'm going to make my R1 560 ohms. I'm going to make my R2 980 ohms. I'm going to make my R3 1.2 kilo ohms, and I'm going to make my R4 330 ohms. Is the writing clear on your screen?
Yeah.
Okay. I'm going to put these up here also. 560 ohms, 980 ohms, 1.2 kilo ohms, and 330 ohms. And then fill this in. There's a total here. Total 20 volts. Move this paper up a little bit, like that. Okay, so Pull out the handy dandy calculator. And how many of you have the confidence to be able to say that they have R total already? And then reciprocal plus
60 reciprocal plus 180. Okay, that's 1.2 times 3. 1.23 plus 330.
Okay. All right. Don't shout out the answer. So let me do a check. So Izar, do you have an R total already? Yes or no? If you don't, not to worry, because I haven't really had a whole lot of time to explain this type of circuit to any of you. But Izar, do you happen to have an R total yet?
No.
Oh, it's all right. Ivan, do you happen to have an R total yet?
Not yet.
You do? Okay. Oh, not yet. Okay. Victor, do you happen to have an R total yet?
Negative.
Okay. How about Edwin?
No.
How about Gerardo?
No, still working on it.
Okay. All right. I'll show you a fast way to do this. Brandon?
I do.
Okay. Give me the first digit.
You said for our total, right?
Yep.
6.
First digit. First digit.
6.
First digit's a 6. No, it won't work.
Darn it.
It's okay. It's okay. It's okay. I mean, I could be wrong too, but okay. Let me explain to you how we're going to work this. The approach is very fast and easy. This is one of several different kinds of circuits. This is a very popular circuit. This one is defined as what we call a parallel series. Okay, it's not a series parallel. I'm sorry. Let me write down. It's not a series parallel, it's a parallel series. And the reason why it's a parallel series is this. From the voltage source, if we look at the voltage source, if we come out the negative lead, we hit a node, and the node is identified as B, yes? There are no series elements between this negative plate and point B. No series elements whatsoever. What happens at point B? The circuit splits. So it looks like we have multiple paths if we look at the bottom of the circuit. Are we in agreement there?
Mm-hmm.
If you look at the top of the circuit, the positive plate to point A, there is only a bare wire going to point A. There is no series element, no E's, no diodes, no resistors, nothing between the positive plate and point A. Once we hit point A, the circuit splits again. That says it's not a series circuit. First and foremost, not series. There's no part of series that belongs in the first part of the name of the circuit. It is, however, a parallel circuit that has series elements in the branches. Remember, the nickname for a series circuit is called string. The nickname for a parallel circuit is called the bank. And the bank is made up of branches. And I have how many branches in this circuit? 2 branches. Each branch has how many resistors in it? 2 resistors. What is the relationship of the 2 resistors? They are in series. So the simple solution for this particular guy is to do what we call a redraw. So we're going to redraw this. So redraw this, we will have our voltage source It stays exactly where it was. We will go to a point A. We will go to a point B. And we will have a branch coming down. We will have a branch coming down. We will have another branch coming down and another branch coming down to here. We will, however, replace the two series with resistors with something we put in between. We can combine this. We will call this an REQ1 and do the same over here. This will be an REQ2. And what is this REQ? REQ stands for equivalent resistance, equivalent R, meaning REQ1 was the combined ohms of 560 in series with 980. We can clearly see they are in series, yes? There's only one current path between them. How do you find the total of resistors that are in series? Don't we simply add those?
Yes.
Okay, so when you go to add, go ahead and confirm this on your calculator, add 560 plus 980. That first branch should have 1.54 kilo ohms, yes? In other words, if I write this out in full, 1540, 1540 ohms, yes? And then now take a look at the second branch. The second branch is has two resistors that are in series, and as they are in series, they add to give us REQ2. So I have 1.2 k ohms plus 330. That will add to become 1,530 ohms, or 1.53 kilo ohms. Yes? Are we good with that so far?
Yes.
So have we taken a 4 resistor circuit and reduced it to a 2 resistor circuit? This is and what is the name of the process, gentlemen? The name of the process is called redrawing. What is the purpose of redrawing? To simplify. Okay, that's the purpose of drawing, is to simplify. So that being said, now we can clearly see why we call this a parallel series circuit, because fundamentally, once we get this down to 2 resistors, this is nothing but a very simple basic parallel circuit that had series elements in them. Therefore, the name is correct in calling this a parallel series circuit. Are we good with this so far?
Mm-hmm.
Yes.
Nice. All right, so now what we're going to do is this. We're going to calculate an R total based on these two guys. Now, there's a couple different ways we can do this. We can use reciprocal method, which is very easy, or we can use a shortcut. Let's just go ahead and use the parallel method for right now. So I have 1540. So what I'm going to do, my calculator, is do 1540 reciprocal, and then add that to 1530 reciprocal equals reciprocal and equals. So my first digit is a 7, yes? It works out to be 700 and change. Could you all calculate that, please?
Yeah, 760.
And change. We want that. We want all those. We need the digits all the way down to 2 digits after the decimal point. So I'll start in sequence. Izar, do you have that calculation?
Not yet.
Okay. Let's see. Ephraim, do you have that calculation? Ephraim? Let me check the chat. Final R total, no. I think you did. Yeah, Ephraim, yeah, that's not going to work. Yeah, so please follow along this explanation. So to do this calculation, let me write out the keystroke sequence on your calculators. It would be, if I start over here, 1540 and you hit your x-1 reciprocal key, and then you hit plus. Then you do 1530, hit your x-1 key, and then hit equals, and then hit your x-1 key again, and hit equals one more time. And if you do so, you should end up with exactly the same answer as Victor. Do you have the final calculator?
Negative.
Okay, follow this keystroke sequence and see if you can generate it. Edwin, do you have the calculated R total?
No, not yet.
Okay, then follow that keystroke sequence. Gerardo, do you have the total?
Not yet.
Okay, Brandon,
Yes.
you recalculated, and this time it does not start with the 6, right?
Sorry, start with a 7. Yes.
Cool. What are my last 2 digits after the decimal point, Brandon?
The last two.
Yeah, after the decimal point.
49.
Good. Okay, hang tight. We'll let the rest of our classmates catch up, because I'm not going to write the number down for people to copy. They'll all copy it and they'll figure it out later. No, we don't do that. I want you to figure it out now while you have, while we have each other. Is anybody having any trouble finding this reciprocal key, the x-1? On some of your calculators, it might be a second function, so look at that function very carefully. Other than that, it should be pretty straightforward. You might see it also shown this way. On some calculators, it might be shown as a 1 over x, okay? So these are the same type of button. The x-1 is the same as a 1 over x. So if your calculator has an 1 over x button instead of x-1, that might help you solve this. So back to you, Izar. Do you have a total for me yet? I think he just found his button. Ivan, do you have a total for me yet?
Yeah, I got one.
Okay, what do you got?
You just want me to say the whole thing?
Yeah, sure.
767.9.
Oh, very good. All right, Victor?
Yes, exactly the same.
Okay, Edwin?
Yeah, I got the answer.
Okay, Gerardo, what do you have?
Same.
Good. Okay, so it is 767.49 ohms. And that's what we'll fill in on the bottom. So we still have, let's see, there's 3 columns, 5 rows. There's 15 cells to fill in on this particular analysis. We are getting there. So what would be the next thing that we would be doing in this analysis? What would be the appropriate next step? Anybody?
We can calculate for I.
Good. All right. And so for calculating for I, presumably this I, since you have a V over here and you have an R over here, let's go ahead and do that. So, cool. All right, so Edwin, do you have a current for us?
Yeah.
Could you read out your current value, please?
Not yet. I'm gonna get it in a second.
Okay, Gerardo, do you have a current value for us yet?
1 second.
Okay.
Do you mean I total?
I total, yes.
I get 26.05 of 06.
There you go. Okay, that would be correct. So this would be,
I get a, yeah, 26.05 milliamps.
won't be 05. 05 would not be what you put on your paper. 26.06 milliamps. Now let me redo this with the rounded off answer, and let's see if I take that back or not. 49 second double E -3. Yeah, definitely. Yeah, even if I use this rounded off answer, your second digit here must be a 6 because your calculated answer shows as being 20.05897. So remember, if we're rounding to this second digit right here, you have to look at the third digit. And if that third digit is 5 or greater than 5, you have to increment this by 1. That's a 6 here, sorry. So instead of 26.05, it would become 26.06. Are we clear on how to round properly on that, everybody?
Yep.
Yes.
Cool. All right. Now, this is exciting. All right, so let's go ahead and fill this in. So our RT, we said, was 767.49 ohms. And then we have an IT. We have an IT here of 26.06 milliamps. All right, well, this is good information. So what do we do with this? My goodness, where do we go from here would be the question. Let me get this up a little higher so we can see more particular piece of paper. And move this all back so we shed a little more light on this. Move this out of the way. We'll get a little more light. Hey, everybody see my paper better now?
Yes, sir.
Cool. All right, so where do we go from here? We still have 1, 2, 3, 4, 5, 6, 7. We still have 8 more cells to figure out. What would we do? If we found one current, have we found our currents?
REQ1 and REQ2's current.
And how would we find REQ1 and REQ2's current?
Current should be equal, shouldn't it, for both?
The current should be equal for both. Why would the current be equal for both? And I'm not saying you're wrong. I'm not saying you're wrong, but I'm asking for a logic. Why would your current be equal for both?
Wouldn't they be different because they have different resistance? So they'll be rationed differently.
That would be a correct observation. That would be correct. These are not the same ohms, although they're very close. They're not the same ohms, so there should be slight difference between them, but because they are so close to each other, the current would be very close to being the same. So both of you are correct. Just with touching the calculator, your gut tells you, well, if I've got 1540 ohms here and I got 1530 ohms here, whatever current happens pretty much splits between them. And I have what, 26.06 milliamps going through the entire circuit. It looks like I might have 13 and change milliamps here and 13 and change milliamps here. That's a very, very good.
Your wireless one's better.
I'm sorry? Who made what comment? Okay, I just wanted to make sure that I didn't miss a comment. And we'll be happy to address those. So what's the fastest way to calculate? There's a couple of different ways we can do this calculation. What's the fastest way to calculate the branch currents? How much current goes here and how much current goes here? How does that 26.06 milliamp split between those two?
Current division?
An approach. What's that?
Current division?
Current divider formula. Could we apply current divider formula? And if you remember, your I'll write it up here, IRX is equal to the value of RX, RT over RX times I total. So it's R total over Rx times I total. Yes, you could do current divider. That is one method. Who's got another method? It's a good method. There's nothing wrong with that. Anybody else got any other ideas? Okay, the simplest way to do things. This is how many volts on the source?
Yes.
20 volts, right? And these are parallel. What is the same in a parallel circuit? Isn't this 20 volts from A? Isn't the 20 volts across this one resistor as well as across this one resistor? Isn't 20 volts found across REQ1 and the same 20 volts is found across REQ2? Is that right or wrong?
Yes.
So the simplest way is, yes, you can do current divider, which is good, button pushing on your calculator, but I'm trying to reduce the number of buttons that you're pushing on your calculator to make it the process smarter, not harder. And so all I'm suggesting to you is this: since we know that we have a parallel circuit here, couldn't we just take the 20 volts and divide by these ohms to get the current? Couldn't we take the 20 volts, divide by these ohms and get that branch current and be done with it? Yes, and that's the simplest way to do it. I would vote for that. So that being said, I'm going to light up the calculator and let's go ahead and take 20 and divide by, what do I have here? 1540, right? Nothing rounded about that answer. That is a solid added number. So everybody take 20 divide by 1540. And what is your branch current there, my friends?
12.98 million. I mean,
Are we rounding errors again, my friends?
12.99.
There you go.
Thank you.
All right. Right. So the first branch has 12.99 milliamps. Yes?
Right, yeah.
All right. Now let's do the second branch. Take 20 and divide by 1530. And how much current is on the second branch, my friends?
13.07 milli.
13.07
Milliamps.
milliamps. Okay. And I've written them on this particular redraw. Yes?
Yes, sir.
Okay. All right. Now that you have these branch currents, that's nice. What do you do with those? Where do we go from here?
You put them respectively in the chart.
No, okay, but which one goes where? REQ1 and REQ2 do not exist on this chart.
Right.
So what do I put where? Who's got a suggestion?
Well,
Victor here.
Victor.
Yeah.
Yes, Victor. Go for it.
Yeah, divide the current for each individual, I don't know, for REQ1 is 560 ohms and plus 980 ohms.
Here.
Yes.
Yes, you're absolutely right, Victor. This, oops, sorry, I moved the camera. All right, so this branch current of 12.99 milliamps flows through the first EQ branch. The first EQ branch was made up of, if we go back to the original circuit, 560 in series with 980. So this branch current of 12.99, which flows through this REQ1, flows through each of these individual resistors of this first branch. I have 12.99 milliamps in that first branch. So after you identify and understand that, this 12.99 milliamps is the current through R1 and is also the current through R2. So now on my chart, this is where I can fill in the 12.99 milliamps, 12.99 milliamps right here, which means I can do the same with REQ's current. Yes, REQ2's current was 1307, right? Milliamps. And the REQ2, was that made up of R3 series with R4? What's the same in a series circuit? Current is the same. So whatever current flows through this branch of REQ2 is the same current that flows through these pair of resistors. So I must have 13.0, what do we say, 7 milliamps flowing in this circuit, which means on the chart I can fill in 13.07
Right.
milliamps. 13.07 milliamps, yes?
Mm-hmm.
Wow. The rest of this is pretty straightforward, right?
Yeah.
Because what do I do for VR1? What do I find? How do I find this voltage here?
Ohm's law.
Ohm's law, exactly. I'm going to multiply this times this in order to get this. And so let's go ahead, do those calculations now, and I'll call you out individually for the answers. So everybody make these calculations in silence. Mm-hmm. Okay, cool. So I'm going to start with VR1. So with VR1, Ephraim, do you have the value for VR1? Okay. Ivan, do you have the value for VR1?
Yeah, I
You
got
got
7.27.
excellent. You are correct. So 0.27 is the voltage here when I multiply this current times these ohms. Okay, I'm looking for VR2. So VR2, Brandon, do you have the value for VR2?
Yes, sir. Is it 12.73?
12.73 volts is correct when I multiply 12.99 milliamps times the 980 ohms. I'm looking for VR3. Edwin, do you have VR3?
Not yet, sir.
That's all right. Gerardo, do you have VR3?
I have 15.68 volts.
Okay. Since I used memory, we can be 1/100th of a decimal place off. It works out to 15.69 volts. I'll accept your 15.68. Nothing's wrong with that at all. Okay, thank you. Victor, do you have VR4?
Yeah, I hope to be
What do you
right.
have, Victor? Sure, read it off.
4.58.
What's that?
4.58.
4.58?
Yes.
I think that's going to be a little off. 1307, you're close. You're close. But 1307 milliamps times 330, so 13.07.
Yeah, I got 350 here. Sorry. That's why.
All right. Okay. Yeah, you were close. So yeah, once you correct it with the 3 ohms, you should be okay. Ephraim, do you have this answer for us now? VR4?
4313.
4.31 volts is correct there, Victor. Very nice. So we filled in the complete VIR chart, yes? Pretty sweet. Pretty sweet. All right. So the lesson again, to do this type of analysis, you have a circuit and you look at it from this perspective. I say we look at it with here's the voltage source. Here's the part that is farthest away from the voltage source. Look at it from this point, looking back in. What do you see on this wire? On this wire, we see 2 resistors. What is their relationship? They are in series. So we can put those 2 that are in series and make them into REQ number 2. If we follow the wire to this node, we see another wire and it has 2 resistors and they are also in series. So we can combine those 2, they become REQ number 1. We reduce the 4 resistors down to 2 resistors. And with 2 resistors, we realize that they are easily calculated in parallel for a total resistance, the total resistance of 767.49 ohms. Fill in our chart, find I total, and then do the rest of the analysis. And the voltage is the last thing we do over here for this particular analysis. We go for the branch currents. We know that in a parallel circuit, 20 volts is in parallel with this resistor, in parallel with this equivalent resistor. So that 20 volts is found here and here. We use Ohm's law to calculate the current. The branch current here worked out to be 12.99. If you took the time to use, current divider formula, you would very well easily end up with the same current. We used Ohm's law of 20 volts divided across 1530 ohms, calculated 13.07 milliamps. Again, if you use current divider, you would end up with the same current. Once you find the branch currents, you take those branch currents, you bring them back to the original circuit. The original circuit for this branch that had 1299 milliamps was through two resistors. So that 12.99 milliamps can be transferred onto your chart here and here. The 1307 milliamps transferred onto your chart here and here. And then Ohm's law is the rest of the story. So if you see a worksheet on several of these types of exercises, do you feel you have the confidence now to be able to do this particular chart with 99.99% accuracy?
Like a pack of Germex, yes.
Only if I round up.
Only if you, yes, you got to remember to round properly. Let's just say round properly, because sometimes when you round, the number stays the same. But that's all good. That's all part of our learning experience. And by raise of hands or by affirmation, how many of you on your calculators have a 1/x key?
I do, Victor.
Victor does. And how many of you have the reciprocal key, the x-1?
I do.
I do.
Okay, most everybody else. All right, so Victor, you just have to remember, when I write down x-1, you're going to use the 1/x key, yes?
I have both.
Oh, you have both. Wow, how special you are. Wow, fancy calculator. All right, so here's the thing. When you do this particular analysis, the task that I haven't presented to you all yet, in addition to this week, you will get additional worksheets on something very similar to this exercise, but you will also be asked to verify these numbers by going on TINA. By going on TINA and building this circuit this way, and if you pop in all the numbers and you hook up all the voltage, the digital multimeters, and hook up ammeters correctly, you will be able to see all the numbers verified here using TINA. So that would be the follow-up exercise that I have not yet assigned to you all. Any questions on this, my friends?
No, sir.
All right, this is a good talk. I'm very happy with the progress of the lesson so far. So we all know what we need to do with respect to our soldering project. And the forthcoming, you'll have probably 2 of these types of exercises to do. For this particular exercise that we have done, you will be building this on TINA and verifying these values on TINA. And I will reiterate all of that in Canvas. This session is being recorded, but I have found out that the recordings have been slow in coming back to us from our friends in, who does this? Zoom, yes. That they're a little slow in coming back to us, so you may not see the recording loaded anytime soon. And even if I am able to load it, I would prefer to load it in Studio so it's in one place and everybody just goes to Studio to find it. But since you all can't see Studio, what I'll do is I'll create at the beginning of each week, the remaining weeks that we have, I'll have a video folder, and that's where I'll store the video. Is that okay with everybody?
Sounds good.
Okay, and hopefully the video is not so large that I can't port it, because I did a 19-minute upload. It was the instructional video for this was 19 minutes for the soldering exercise, and our discussion now has been on since 6 o'clock. So we're 7:15 now. that's over an hour. It should be an incredibly large file. If I'm not able to load it, I will let you guys know as well. So, okay. And yeah, Studio is an add-on. Canvas, yeah, can you upload it in YouTube? That works as an alternative. That's a good suggestion also, Ephraim. I have a YouTube channel, so I'll see what, I haven't posted any of our Zoom output. It's an MP4, so I suspect it should be able to load up fine in YouTube. So that's a good suggestion. I'll use that as another avenue for us. Okay, good. Any questions that you all have of me? Good
I
luck.
have one.
Yes, who is Edwin?
This is Edwin. Just
Yes.
to get a full sense of where we're going with the class,
Yeah.
we're pretty much tackling, I get the sense of two general areas. One is to be able to use Tina and that software to kind of project or give us the figures that you just did on paper.
Mm-hmm.
And the other one is to actually do those by hand. Am I right?
Yes, for this particular part of what we're doing, that is correct. And then we also have our soldering projects, and our soldering projects are not confined to what it is that you have in your hands. There's also a laser wood cutting exercise, which you all have to download the appropriate software and do the designs for the laser cut. And so the plan there is once everybody submits their laser cut designs to Nabil, Nabil will go ahead and cut them, and everybody will be able to fabricate on our laser. Well, all of your designs will be fabricated on our laser cutter at school. You won't be able to collect them until we are able to go back, but at least we will have them in our hands as another part of the fabrication process.
Thank you.
You're welcome. Good question. Any other questions? Okay, I'm sure as other questions arise, you know I'm accessible through Canvas, and I try my best to answer within a 24-hour business day. So don't hesitate to alert me if I forget something, put something in the wrong place, remind. So I don't take offense to any of your suggestions because they're all helpful to what we do as a collective. So I thank you all very, very much for your rapt attention. And I look forward to the next time that we will meet again. We'll meet again regularly on Tuesdays at the 6 o'clock hour, and we'll have more to do. But keep an eye out for Canvas because you'll have assignments during the course of the week and things for you to upload into Canvas in the upload boxes. Okay? Okay, so with that, thank you all very much for your kind attention, and I look forward to chatting with you on Canvas. All right? So I'm going to stop the recording. Thank you very much. Have a great evening.
Bye-bye.
You do.